Good evening, guys. Today we are going to talk about one of the very famous theory, that is a drive reduction theory given by Clark Hull. So this theory basically talks about about the motivation behind our behaviors, what motivates us or what pulls us to do things that we do, and how do we do things, and what basically what uh, decides the direction of our behavior. So let's see about what this theory talks about. So, who was Clark Hull? Clark Hull was one of the famous psychologists, and he is also known for this theory, that is a drive reduction theory. So he was working at Yale University when he came up with this theory, and obviously, as you can imagine, he was inspired by the behaviorist and psychologist that came before him, like the Ivan Pavlov, Edward Thorndike, and Charles Darwin. Also John B. Watson, who was basically talking about the behaviorism and how our focus should be on the overt behavior rather than something that we are not able to see, and the psychological processes. So the behaviorists were talking about how the emphasis should be given on the our behavior and our overt thinking processes. I mean, sorry, the our overt behavior. So Hull was inspired from this behaviorist, and according to his theory, he talks about this principle of homeostasis. Homeostasis, that is, he tells that the drive that we have, the drive, you can imagine what drive is. Our basic needs, something that does very that drives us, for example, hunger, thirst, our libido, etc. These are the things, the drives we have. And when this drive is there, when this need is there, our homeostasis, or the balance, the state of balance in our body, in our system, our basic system is disturbed. So according to this drive reduction theory, what Hull tries to tell us, our whatever we do, whatever behaviors we do is to keep this balance, this homeostasis in us. So our behavior, the direction of our behavior is determined by this homeostasis or the drive basically. And further, this theory was developed by Kenneth Spence. So now we are going to look at, we are not going to see how the theory evolved after Hull. We will be only looking at the theory that Hull is talking about, and according to him, what is drive reduction theory and what is, what determines our behavior in general. So what does his theory basically talks about? So his theory basically talks about that, as I was mentioning before, that our drive is, so he defines drive as a state of arousal or tension, that when we are not, our needs are not fulfilled and there is a need in us, and a drive arises. And when a drive arises, this gives us a motivation. So, because when the drive is there, that means our survival is threatened. So in order to get over this unpleasant state of tension, what will we do? We will do some behaviors to reduce this tension and restore the homeostasis or balance in our body. So according to her, basically this is what is happening in us. That is, we are trying to overcome this tension, or what this state of tension and this drive, and we are trying to bring back the balance or homeostasis. So to reduce this tension, what we will do, we will we will begin to seek for the ways to satisfy these needs, that is reducing this drive. So according to this theory, any behavior that reduces the drive, that is, uh, for example, one of our very basic drivers, hunger and thirst. So in order to reduce this drive, this state of tension, we will go in search of food and thirst. And once the drive is reduced, the homeostasis is restored in our body. And this drive reduction is the positive reinforcement according to her. We don't need any other reinforcement. The drive reduction is the positive in reinforcement according to her. Now he also came up with 16 postulates. That is, what are postulates? Postulates are basically assumptions that is very difficult to be tested. So postulates, he came up with major 16 postulates in his 1943 theory. So Hull came up with this drive reduction theory in 1943, and again he revised his theory in 1952. Now this postulates was a major part of his 1943 theory. So let's look at what this postulates are talking about. So postulate number one is that sensing the external environment and the stimulus streams. So initially, most of the behaviorists like Ivan Pavlov and Skinner all were talking about SR, that is a stimulus response theory. So there will be a stimulus presented to the organism or the human being or anything, and there is a response. And in the classical conditioning theory, the theorist or the behaviorist were talking about how they can pair two stimulus or pair two responses and convert one unconditional response to a conditioned response, that is SR. Now in Hull's theory, he came up with a small s, that is a stimulus trace, that is in between of the stimulus and the response, and a small r, that is between as the stimulus trace and the response. So what are this small s and the small r? So as you can see, the S is for the stimulus trace. So when Hull defines what, according to Hull, the stimulus trace, what he means by stimulus trace is, the neural stimulation, that is taking place in us. That is, for example, I see a foot, okay, that is a stimulus. So when a stimulus is there, something neural stimulation is happening in my body. My hunger is triggered, or I start salivating. That is the stimulus trace. And then comes R. R is also the firing of motor neuron. So before I go in search or to take that food, uh, there is what neural functions going behind the response or the R, the motor response. So, for example, if R is me going and grabbing the food, that is the response, there might be a small r or the firing of the neuron to, me thinking about, okay, I need to go and get the food. Then the neural responses playing in behind of this overt response that take place before this response is the small r. So according to Hull, we sense the external environment and the stimulus trace is there before, after the stimulus is, we receive a stimulus, and before a response taking place, there is a stimulus trace, and also there is a small r or the neural reaction. Now let's go to the second postulate. Now, postulate 2. So, the postulate 2 talks about the interaction of the sensory impulses or the stimulus. So, basically, uh, Hull tells that there are more than one stimulus before a response is happening. Okay, so in the all the theories that came before Hull, we were only talking about a one single stimuli, or single stimuli or a sensory impulse, that is that an organism is receiving. But Hull tells or argues that there is not one stimuli or one sensory impulses. There are a lot of stimuli. There is an interaction of a stimuli that is taking place, that is leading to a stimulus trace, and there is a neural in what reaction, and there is a response happening. So Hull tells that it's not that simple. It's not just one stimulus that is giving a response. It is an interaction of many sensory impulses that gives us a response. Now let's look at the third postulate, that is the unlearned behavior. So here, how the theories that came before Hull talks about association between two stimuluses, or a stimulus and a response, and two responses, etc. But here Hull gives the emphasis on this our drive and this our innate neural mechanisms. So according to her, we don't need to learn a behavior if our drive is getting reduced every time. Only if our innate responses are not enough, or our innate responses or our previously learned responses is not satisfying our drive or reducing our drive, then only we will have the motivation to learn a new responses. That is, then only we will learn a new response. So until and unless our innate responses fail us, our innate neural mechanisms fail us, then only we will try to, or we will start learning something, or there is a reason to learn a new response. Now let's look at the postulate 4, that is the contiguity and drive reduction as necessary conditions for learning. So here also Hull emphasizes the need of emphasizes on the fact that in order for learning to occur, there should be a drive reduction or a need satisfaction. That is the primary reinforcement. So reducing this, having a biological need, and uh, when that biological need is satisfied, then only association between a stimulus and response will happen. So, for example, suppose takes Paulo's experiment as an example. So the dog, we are giving dog the food and we are trying to associate, or uh, we are trying to make the dog learn that learn that when he hear the bell, he salivates. So we are trying to condition or pair the food and the bell. But here in the conditioning, the pairing happens only because the food is able to reduce the drive of the dog. Suppose the dog was not interested in the food at all, or instead of food we gave something that is not reducing the drive of the dog, then this association or learning wouldn't have taken place. So here the Hull is trying to emphasize on the satisfaction of the need and the drive reduction. Then only if the drive reduction is taking place, then only learning will happen. So for Hull, the reinforcement was drive reduction, not anything other. It was the drive reduction. And he also came up with the concept of habit strength. For Hull, habit strength is the strength of association between a stimulus and response. What do you mean by strength and strength of a association? So when we tell strength of an association, so when I tell when the bell is rung, when the dog suddenly remembers about the food or suddenly salivates, that means the strength of the association is very huge, very large. But if when we ring the bell and if the dog doesn't salivate, that what does that mean? The association is very weak. So according to her, there should be a habit strength. He came up with the concept of habit strength, and uh, he also came up with a formula that is, as you can see, SHR. So the uh, this is how we denounce habit strength. So according to Hull's theory, SHR stands for the habit strength, and he gave a mathematical formula that describes the relationship of this SHR, or the stimulus response, and the number of reinforced pairings. So you can see that this is the formula. So SHR is the habit strength and N is the number of reinforced pairing. So for example, I try to ring the bell and give the food to the dog one time, then N is 1. Then I again rang the bell and give the food to the dog. I repeated this 3 to 4 times or 5 times. Then what does the N denotes? 5. Okay, so N is the number of reinforced pairing, and as the number of reinforced pairing between a stimulus and a response goes up, the habit strength also goes up. I think it's very pretty clear from the mathematical formula. That is, this is the habit strength, and as N goes up, what happens? This also goes up. The association or the habit strength also goes up. Yeah, and but this formula also tells us one more thing, that is a negatively accelerated learning curve, which means that the reinforced pairing have more of an effect on learning than do later ones. So for example, I rang the bell first and gave the foot. That was the first pairing, right? So this pairing have a more effect rather than the later reinforcement. So the ones that I do first has more of what, a strength rather than the later reinforced pairings that I do for the dog. Let's look at the postulate 5, that is a stimulus generalization. So in this postulate, it is very easy postulate to understand. This concept is very similar to the generalization concept from the classical conditioning theory, where it talks about how a similar stimulus can, or we can generalize the response to, or the condition respond to other similar stimulus. Similarly, here Hull also talks about the same, that is stimulus generalization means the ability of a particular stimulus to elicit a condition response on the same response, uh, because of the similarity it has with the stimulus that already elicits that same response. Okay, uh, for example, let me see. So we were talking about the uh, Pavlov's conditioning, where the experiment where the dog was given food and it was conditioned with, or the paired food was paired with the bell, and the dog salivates from when the dog was hearing the bell. So thus, if we replace the bell with some other stimulus that is similar to the bell, it also have what, it may also have the ability to elicit the same response, that is the salivation. So what happens here, that it has the uh, this ability of the stimulus, or the whatever we replace the bell with, if the stimulus also elicit the same response, that is the salivation, the Hull argues that it has a generalized habit strength. Okay, so if another similar stimulus is also able to produce or elicit the same response, it has a generalized habit strength. And you can associate this stimulus, I mean this postulate, with our Thorndike's identical elements theory of the transfer of training. Okay, now let's go to the next postulate. Okay, so the postulate 6 is the stimuli associated with drives. So this postulate talks about how, I was talking about how drive is the main motivating factor behind each responses or each behavior that we are doing. So in this postulate 6, Hull talks about how the specific try makes it possible to teach the animal or bring new learnings to the animal or human beings, whoever we are doing this conditioning. So for example, uh, uh, we know how rats are trained to get into the maze learning, how the giving reinforcement through the maze, or at the end of the maze, the rat is able to find the route to the end of the maze. So, and behaviorist and theorist and psychologist have done a lot of experiments to see how we can make animal do different kinds of things. So in this postulate 6, Hull is talking how, emphasizing on how we can make animal learn new things using different drive. So for example, I can give food as one reinforcement to make the rat do one particular thing, that is get through the maze, and use the another drive, that is the thirst or drinking water. Okay, that as to make the rat learn another behavior, that is pressing the lever or jumping up and down, whatever it is. So that is, we can use specific drive stimuli to teach the animal or the organism or human being for that matter to behave in another way, one way under one drive and another way under another drive. Okay, it's as simple as that. Now let's look at postulate 7, that is a reaction potential as a function of drive and habit strength. Okay, this is one from this postulate he also derived one equation of reaction potential, that is SER equal to SHR into D. So from the previous postulates we see that SHR is the habit strength. So what was habit strength? Habit strength is the association, the strength of the association between a stimulus and the response. So the strength of the association between the bell and the food given to the dog. So that is the SHR. Now he talks about what is reaction potential, what are we trying to see here. So reaction potential is nothing other than the likelihood of a learned response being made. So I am trying to teach the dog, I paired the bell and the foot, okay, in Pavlov's experiment. So when Pavlov paired the bell and the foot, uh, and we are trying to see if the bell is able to elicit the same response, that is a salivation. So how much likely is that when the bell is ringing the salivation will happen? That is the reaction potential, that is the probability or the likelihood of a learned response being made at any given moment. Okay, that is the reaction potential. So the reaction potential, the likelihood of the learned response being elicited, is a function of both the habit strength and the drive. So it depends upon the, so for example, I paired the bell and the foot and the I try to condition the dog to the bell and conditioned the bell in such a way that the dog salivates. But so I did all the conditioning. Okay, that's over. And the next day or the day after that, I try to test once again, trying to ring the bell and see if the dog is able to salivate. So, what is the likelihood of that the dog will salivate? So, the likelihood depends upon how hungry the dog is, right? So, if the dog is not hungry, it's very less likely that the dog will not salivate. So, the less likelihood that the dog will salivate. Okay, so that is the drive. So, a drive should be there for the dog to salivate or the learned response to being made. And the second is the habit strength or the strong association between the bell and the foot. Okay, so it's not only the association or the condition that has the power here to bring the learned responses, but drive also plays a very major role. Now the next is the postulate 8, that is responding causes fatigue which operates against the elicitation of a conditioned response. Okay, now here Hull brings in a separate variable, that is a reactive inhibition. Okay, so we know that when we are trying to pair something, pair I mean one stimulus to with a neutral stimulus with a stimulus that already elicits a response. When we are trying to pair, the animal is walking again and again. So how much ever repeating experiments we do, the animal is also trying to respond to that particular stimuli. So when we are trying to like give this, while we are doing this experiment, the activity, the amount of work that is involving in performing a task causes what? Fatigue. So for example, let's take maze learning. So in the maze learning, we are giving food as a reinforcement, yes, but suppose we are doing it again and again and the rat is trying to get out of the maze to get food as the reinforcement. So we did this one time, two times, three times, 10 times, 20 times. What will happen after we keep on doing it? Fatigue will happen, right? The amount of work is too much for the rat. So here the fatigue, what will this fatigue do? So what will happen if we are fatigued although there is a reinforcement? What will happen? we will stop doing work even though there is a reinforcement. That is, here extinction can, Hull tells that extinction can also happen um, when there is a fatigue or the buildup of a reactive inhibition. So for example, let's talk about a real life example. That is, you are in a work in a very toxic culture environment. So there is a reinforcement, huge reinforcement, that is the money. So here money is a very huge reinforcement and you are ready to do this work again and again, uh, even because of this reinforcement. But after a lot and lot of work, what happens? Burnout happens. You are not able to function mentally or physically. So in that case, what will happen? You chose not to do the work, and what happened? The extinction happened, or you stop responding to this reinforcement. That is the reactive inhibition. Okay. So here the reactive inhibition also talks about a reminiscence effect. So what is reminiscence effect? The reminiscence effect talks about how our performance increases when a period of rest is given after we are need to do work again and again. So suppose our company is making us do work again and again and again. So there is a, what happens? Reactive inhibition happens, fatigue happens, and our performance tend to go down. So suddenly, what our company does is will give us a vacation or a rest period, and after the vacation, when the employee joins back, what happens? The performance improves. So when there is a period of uh, rest, there is a improvement of performance. When there is a cessation of practice or there is a stop in this doing this work again and again, that is the reminiscence effect. So this concept of reactive inhibition explains what why this reminiscence effect happens. Now the postulate 9, it talks about the learned response of not responding. So we talked in the last postulate, we were talking about what? Reactive inhibition, or how fatigue makes the extinction happen. Fatigue makes us uh, makes the learn makes decreases the likelihood of not responding. So here in the postulate 9, the Hull talks about how this fatigue, so when fatigue happens, what we will do? We won't respond. So when we are not respond, the fatigue will go down. So we will link the fatigue and the not responding, right? So there is a chance we associate both of it, and we learn that we, or the animal or the organism, we learn that the fatigue in itself, the not responding in itself is very uh, reinforcing. So if we are not responding, there is no fatigue. So that in itself is reinforcing. It acts as a negative reinforcement there. It takes away the fatigue when we are not responding. And for this, the Hull called it as the conditioned inhibition. There is the pairing happens between the fatigue and the non-responding. Um, the not responding and the absence of fatigue is paired, and a conditioned inhibition happens. So both, so we were talking about how SCR, or the reaction potential, is a function of the habit strength and the drive. Only if there is habit strength and the presence of a drive, the likelihood of the learned response will go up. So with this equation, Hull also added the reactive inhibition and the conditioned inhibition. So the likelihood of uh, a learned response happening depends on both the habit strength, the drive, and also on minus the reactive inhibition and the conditioned inhibition. Both the reactive inhibition and the conditioned inhibition will reduce the likelihood of this particular habit or this particular learned response from happening. Okay, so that is the postulate 9. So, and the postulate 10, that is the factors tending to inhibit a learned response change from moment to moment. So Hull talks about another factor, that is the inhibitory potentiality. So he tells that or he argues that from moment to moment there is a potential for the learned response not happening, that is the inhibitory potentiality. And this factor operates on the elicitation of the learned responses, and it varies from moment to moment. So it's basically talk about the probability or the statistics, that how from moment to moment there might be various factors that will inhibit the learned response from happening. And he called it what? The inhibitory potentiality, and he gave the symbol SOR. And he also added that to the whole equation, that is a momentary effective reaction potential. At a moment, the likelihood of the learned response happening depends upon what, on how many factors, on the habit strength, the drive, the reactive inhibition, the conditioned inhibition, and also on the oscillation effect. So the oscillation effect explains why a learned response may be elicited on one trial but not on next trial. So although these are the main factors that are affecting or that determines the probability or likelihood at which organism responds to a particular stimuli, there might be other potential or probability factors that might affect at the moment, from one moment to another. Okay, in this postgate 11, what the Hull talks about is momentary effective reaction potential must exceed a certain value before a learned response can occur. So what he talks about here is he brings in a new variable, that is the reaction threshold or the SLR. So according to this postulate, Hull argues that the effective reaction potential must exceed a certain threshold for a learned response to happen. So suppose a learned response will only happen only if it goes about a certain threshold, a reaction threshold. Okay, that's it. That is, there is a this SCR. So for example, let's go back to the theory. That is, I mean, not the theory, the equation. So what was the SCR equal to? According to the equation, SCR equal to habit strength into drive minus reactive inhibition plus the conditioned inhibition and also the oscillation effect. So according to the SCR is a function of all those variables together. So only if all those variables coming together is above a particular threshold, a reaction threshold, then only that response will occur or that response will be emitted. Now the postulate 12, the probability that a learned response will be made is a combined function of SCR, SOR and SLR. I hope that is self-explanatory. That is, for a learned response to happen, the SOR might be what the probability or the potential should be high, and at the same time the SLR, it should be above a certain reaction threshold, and the SCR, that is the what effective reaction potential. So the learned response, the probability that a response will be made is a function of all these things. So let's look at the postulate 13. That is, what is uh, the greater the value of SCR, the shorter will be the latency between S and R. So the latency, what do we think the latency between S and R is? So basically it is the time between the presentation of the stimulus and its learned response. So I am ringing the bell to the dog, and the dog is taking a lot of time to salivate. That means the STR or the latency is very huge. Okay, so the greater the value of SCR, the greater the reaction potential is, the lesser the time between the presentation is. Okay, so the postulate simply states that the reaction time between the onset of the stimulus and the elicitation of a learned response goes down as the value of SCR goes up. Now the postulate 14. The postulate 14 talks about the value of SCR, or the momentary effective reaction potential, will determine resistance to inhibition. Extinction. Resistant to extinction. That is, higher the likelihood, or the higher the momentary reaction potential is, greater the number of known reinforced responses that have to be made before extinction takes place. Okay. So for suppose I did so you think about the equation. So in the for this momentary reaction potential to be higher, what are the factors that should be there? There should be habit strength, drive, reactive inhibition, momentary, I mean conditioned inhibition, oscillation effect, etc. So there are a lot of variables that come in determining this momentary reaction potential. So this should be, if this value is greater, that means it will be very hard for us to uh, take this learning away, or for the extinction to happen. Okay. So Hull used N to symbolize the number of known reinforced trials that occurred before extinction resulted. So for the extinction to happen, the number of non-reinforced trials should be very high. Okay. So if SCR is greater, okay, in that case N should be very high for the extinction to happen. Now let's look at the postulate 50. That is, the amplitude of a conditioned response varies directly with SCR. Okay. Now here he talks about the amplitude of a response. So how intensity how a response is. It will depend upon the what our momentary reaction potential. So some learned responses occur in degrees, that is salivation or galvanic skin response. We can measure how intense our salivation is, or how our galvanic skin response is. Most of the responses are what, measurable. The amplitude we can measure, or the degrees we can look at. So when the condition response is one that can occur in degrees, its magnitude will be directly related to the size of SCR, or what, the uh, momentary reactive effective reaction potential. So Hull used A to symbolize the response amplitude. So for the amplitude to be higher, this SCR should be higher. Now the last postulate, that is the postulate 60. It talks about when two or more incompatible responses tend to be elicited in the same situation, the one with the greatest SCR will occur. That is, so I tried, so let's imagine I tried to reinforce food with bell, and at the same time I reinforced bell to something other like the water or any other stimulus. Okay. So I rang the bell. So what do you think, which response will be elicited? Okay, so according to this postulate, the response elicited will depend upon which has the greatest momentary reaction potential. That is, which has more habit strength, which has more drive. So if I am trying to, if I did pair the bell with water and the food, and I rang the bell, and suppose the habit strength is more for food, it will salivate. Okay. So the response will be elicited regarding the food, not the water. So and so that is one factor that comes under SCR. And drive, if the dog is more hungry, the dog will elicit response according to that. So if there is an incompatible responses, the response incompat there is incompatible responses, the elicited response, okay, in this situation depends upon the greatest SCR. Now here let's look at so in the beginning I was talking about how Hull talked about this theory in 1943 and also in 1952. So there are some major differences in his 1943 theory and also the 1952 theory. So in we will look at what were the changes that happens in his 1952 theory. One is the incentive motivation. So in his all his experiments, it was seen that he did not give emphasis on the size of the reinforcement. So in the and also the it indicated that the size of reinforcement didn't affect the learning. Okay, but later on in his 1952 theory, he emphasized on the size of reinforcement, and in the experiments it was seen that uh, the size of the reinforcement will change the size in which we perform, or we perform differently as the size of incentives or the size of reinforcement differ. So that is, while learning, when you are learning something, when I am trying to um, associate one stimulus with other, or try to teach you something, or associate pair something, the size of incentive or size of reinforcement doesn't matter. But after you learn something, when I'm trying to get that response from you, the reinforcement that I give or the incentive that I give, uh, well, that incentive will determine the way you perform. Okay, the performance is linked with the size of the incentive, and the rapid change in this performance when there is a change in the reinforcement size, that is the Crespi effect. So in the according to this, for example, when I'm trying to associate money with work that I do, so in the learning phase, the money that I receive from my employer won't affect the work that I do. Okay, so in that learning process, how much ever money I get, it will I might perform the same way. My learning will happen. Even if it is small amount or the bigger amount, the size of the reinforcement doesn't matter. But once I learn things, after the learning happens, if you give me small money, I will perform accordingly. If you give bigger money, I will perform in another way. So I perform, or people perform differently as the size of incentive, or incentive he denoted incentive as a K varies. And the second difference was the stimulus intensity dynamism. Okay, it basically indicates that the greater the intensity of a stimulus, the greater the probability that a learned response will be elicited. So if the way I ring the bell, if the sound is very intense, okay, the probability of the response being elicited will also increase. That's it. Hmm? So Hull's formula was revised, where he added both the stimulus intensity and also that is V, and also he added the incentive, the size of the incentive or the size of the reinforcement, that is K. Okay. Now change from drive reduction to drive stimulus reduction. So basically in the starting, Hull called his theory what? The drive reduction theory of learning. But later he called his theory the drive stimulus reduction. Why? Because he so when a learning or some when a learning occur or a behavior occurring, okay, so there, before the drive is reduced, there is a drive stimuli that is reduced. So uh, let's look at an example where I have this drive that is uh, thirst. Okay, and I need water in order to satisfy my need or reduce my drive. So I go and drink the drive, I mean the water. So from the experiments, Hull show that here the stimulus drive is reduced rather than thirst, the basic thirst, the drive being reduced. It is the stimulus reduction that is taking place before the drive reduction. That is my when I'm seeing the water and going and drinking the water, the stimulus drive reduction is the one that is happening. So it will take time for the water to reach my stomach and satisfy my drive. But initially what is happening? Only the stimulus reduction is happening. Okay, stimulus drive reduction. So, and in the next major difference from his 1943 theory and 1952 theory is the fractional antedating goal response. So here this is also a very basic concept, or it's a very similar concept with that of our higher order conditioning from the classical conditioning. You know how when we pair a stimulus, neutral stimulus, to a stimulus that elicits a response, we can also link the one that we condition to another higher order stimulus. Okay, so suppose I am conditioning bell and foot. Now I can also bring another stimulus, for example light, and condition the light and the bell. So when I try to condition the light and the bell, this dog might start salivating even in the presence of light. It might not need this bulb. Okay. Okay, so when a neutral stimulus is consistently paired with primary reinforcement, it takes on reinforcing property of its own. That is, it becomes a secondary reinforcer. That is, so here when we are talking about food is the primary reinforcer. That is, food is the one that is eliciting the salivation response. When I'm pairing this food with another stimulus, that is a bell is the secondary reinforcer. So in our daily life example, when it comes to our daily life, money is an excellent example of what? A secondary reinforcer. That is, money will give us, reinforce us to do anything, while our primary response is other basic thing like the food, the clothing, the space, and other things. But money here act as a secondary reinforcer. So the fractional antedating goal response is the conditioned response to stimuli experienced prior to ingestion of food. Okay, so the RG, or the fractional antedating goal, is happening uh, that is happens before the drive reduction. Okay, so here you can see this antedating, a fractional antedating goal response. So there is a condition stimuli. It's not paired, it's before pairing. Now before pairing only, food is able to bring the responses like chewing, licking, and salivating. Okay, only, so here that they are trying to pair the conditioned stimulus and also the unconditioned stimulus, that is the food. After pairing, what will happen? This conditioned stimulus will be able to produce this responses, this chewing, licking, and salivating. In the absence of food, this conditioned stimulus will be able to elicit these responses. So after pairing, what happens? The conditioned stimulus will be able to produce the conditioned response, or the chewing, licking, and salivating. Okay. So one of the main questions that might arise into our mind is, so what is the difference between the concept of secondary reinforcers or the higher order conditioning and this fractional antedating response? So here in this fractional antedating response, the Hull talks about uh, so talks about or emphasis on the fact that not every stimulus has the capability to become secondary reinforcers. So suppose let's take the maze learning as an example, and the rat is able to learn to travel through the maze and reach the end of the maze through reinforcers like foot. So while the rat is traveling through the maze, suppose there are a lot of stimulus like light or in many other things, will all of them become secondary reinforcers? No, only a few become secondary reinforcers. So what are those stimulus that become, secondary reinforcers, or the things that will elicit some learned responses? So the stimulus that will give us the, brings us more closer to our goal, or that is eliciting this that is linking our uh, response to our stimulus are the ones that will become the secondary reinforcers. So let's look at this example here, that is an example of Sheeny, a human on the human level. So here 12 o'clock new. Okay, It is one of the reinforcer, acts as a secondary reinforcer, even though food is our primary reinforcer. And salivation happens at the thought of the food. Here there is a stimulus trees, or there is a smallest happening, that is the thought of the food, then only what will happen, salivation will happen. When the salivation happen, what will we do, our direction of behavior is influenced, or we act accordingly and we get out of our chair. Then the sight of the door, and again for us to go out of the door, what must happen, there is a thought of food and there is a salivation, and again we get out of the door. So all these uh, things, like, get the sight of the door, 12 o'clock noon, sight of student union, and sight of food, all of these are becoming secondary reinforcers, because this is bringing us close to our goal. There is a fraction of the goal goal response, that is the eating. So there must be a fraction of this anti-eating, I mean the fraction of the goal response. That's why it's called the fractional anti-dating response. Then only it has the ability to become the secondary reinforcer and elicit such responses. Okay, now let's conclude the theory. So this is a summary of Hull's theory. So here we can, as we can see, there are independent variables, intervening variables, and dependent variables. So what are the independent variables? What do you mean by independent variables? The variables that has the that we have the ability to change. So for example, the work, number of reinforcement, total drive, and this is the amount of reinforcement, and the stimulus intensity. These are the stimulus or the variables that we have control on. So all these independent variables we can change. Okay, this all of these are in our control. And what are the intervening variables? Let's talk about the intervening variables. What is IR? The reactive inhibition. What is SR? That is a conditioned inhibition. And SHR, habit strength, the drive, sorry, the drive stimulus, then the drive, then comes the incentive motivation and the stimulus strength. These comes under the intervening variables, that is the result of the independent variables. And you can see this arrows denote on the variables that is affected by the independent variables. As you can see, work is the one that is affecting what, the reactive inhibition. Why? Because as the amount of work increase, the reactive inhibition increase, fatigue increases, reactive inhibition also increase. And at the same time, the N, that is the number of prior reinforcement, is what is majorly affecting this what, conditioned inhibition. What is conditioned inhibition? They because a human being or an organism or animal gets conditioned or pairs the fatigue and or conditions the not responding as a reinforcement. Okay, that is the SIR, and that is related to the independent variable number of prior reinforcement. And number of prior reinforcement also main thing that is affecting our what, uh, habit strength. As it goes up, the habit strength also goes up. And comes the TD, or the total drive. What are the things that come under total drive? Is stimulus drive and our drive, for example. And K, what is K? K is the incentive motivation we have, and the V is the stimulus strength, and all of those result in the SCR, or what is SCR? The reactive inhibition. And sorry, not reactive inhibition, reaction potential. And what is SCR? SCR is the effective reaction potential. And for the effective reaction potential to come, there should be one more presence of IR. What is IR? IR is the combination of reactive inhibition and also the conditioned inhibition. When we add both of this, we get SER, or effective reaction potential. And the effective reaction potential, there comes oscillation effect and the stimulus threshold. And or the response, sorry, not the stimulus threshold, response threshold. And when it's linked with both of them, we get the momentary effective reaction potential. And what are the dependent variables? What is the result of all these intervening variables, or the independent variable acting upon the intervening variables? That is our dependent variables, or the response amplitude, the response latency, the trials to inhibit extinction, and the probability of a response happening. Okay, so this is the summary of Hull's theory, and this is what was Hull talking about in his very famous theory, that is the drive reduction theory, or as it was later called, drive stimulus reduction theory.